Good morning, students. Today we are going to see permutation. Last class, what we have seen factorial and addition, multiplication, principle of counting. Is it? Okay. Before getting into the concept permutation, I'll give you an example. If suppose we are taking three numbers 1, 2 and 3. Okay, so we are taking three numbers 1, 2, 3. How many ways we can write this 1, 2, 3? Okay, how many ways we can make a number using 1, 2, 3? So how can we can write it as 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. Is it right? So using this number 1, 2, 3, we arrange some other numbers. Is that clear? Using this 1, 2, 3, we have arranged this 1, 2, 3 as a different types. Okay. So this is your order of arrangement. That is, we are arranging this number 1, 2, 3. Okay, in this order, right? So this writing order of arrangement is your permutation. Okay, one more example I'll tell you. Suppose if we take three fruits, apple, grapes, banana, to make a fruit salad. How many fruits we are taking? Apple, grapes, banana. So how can we make a salad? Either you can use apple, you can add apple, grape, banana, or first banana, then grapes, then apple, or grapes, apple, banana, or grapes, banana, apple. Correct? So it would be of any order. So if we change the order, it will not affect the fruit salad. So whatever you will add first, definitely you will get a fruit salad, right? So this is your order of arrangement. This is your number of arrangement. Now look at this one. There is a number lock, and that number lock is 1, 2, 3. I'll say with this example. So we have a number lock suitcase. Okay, now that number lock is 1, 2, 3. So now, can I change this order to make a different number of elements? No, because 1, 2, 3 is a code, number lock. So if you use this number only, you can open the suitcase. Otherwise, it will be permanently locked. If you attempt wrongly, it will be locked permanently, right? So number order of arrangement is important. In your first example, it is number of arrangement, and in your second example, this order of arrangement is important, right? That order of arrangement is called permutation. So see your page number 52, definition 2.3. What is permutation? Number of arrangements. That's all. This is a only word. What is your permutation? Number of arrangements. Okay, number of arrangements. That is, if we are taking n things, like 5 things I can take, out of 5 things I can take 2 at a time. So R is your R things at a time we are taking, n total number of things. Is that clear? I'll give you an example here. 10 things are there. We have to take 2 at a time. So what is your n value? 10. What is your r value? 2. Is that clear? So this is your total number of things. This is taking at a time. Okay, so what is your permutation? Number of arrangements can be made out of n things taking r at a time is called permutation, and it is denoted by, how can we denote that permutation? This one, NPR, you have to write this as n p r like this. Okay, so n, we are n things are there, we have to take r at a time. This is the meaning of npr. We have a formula for this NPR formula. What is your NPR formula? N factorial by n minus r factorial. This is formula. So what is your NPR? N factorial by n minus r factorial. N factorial by n minus r factorial. Is that clear? Okay. So this one, what is your 0 factorial answer? 1. So 0 factorial is not 0, it is 1. 0 factorial is 1. NP0, that is n things are there. We have to take 0 at a time now. Answer is 1. So what is your NP0 value? 1. NP1, so n things are there. We are taking 1 at a random, at 1 at a time. So what is the answer? N. NPN is n factorial. Okay, this is all you have to know. 0 factorial 1, NP0 1, NP1 n, NPN is n factorial. Okay, now what is 8P3 value? 8 things are there. We have to take 3 at a time. Correct? What is 6P4? 6 things are there. We have to take 4 at a time. Is that clear? Okay. So 8P3. How can you get the answer? Either you can use this formula n factorial by n minus r factorial, or you can use the shortcut method also. What is this number? 8. How many things we have to take? 3. So 3 times descending order. 8 into 7 into 6. 6P4, how to calculate? Either you can use a formula or you can use a shortcut method. So from 6 descending, how many numbers you have to take? 4 numbers. So 6 into 5 into 4 into 3 is your answer. Is that permutation is clear? Shall we get into the exercise? Take your exercise 2.3. First question. What is given? NP4 equal to 12 of NP2. We want to find out your n value. Okay, so what is given is NP4 equal to 12 of NP2. We want to find out your n value. So here you can use a formula to find out this answer. Okay, so what is given? NP4 equal to 12 of NP2. Correct? Now, what is your NPR formula? What is your NPR formula? N factorial by n minus r factorial. Is that right? So same formula we can take here. So this we can take it as n factorial by, subtract this, n minus 4 factorial, which is equal to 12 of n factorial by n minus 2 factorial. Is that clear? So we can cancel this n factorial and n factorial, and so the next will be 1 by n minus 4 factorial equal to 12 by this. We can take till n minus 4 so that you can cancel, right? So this we can take it as n minus 2, n minus 3, n minus 4 factorial. So this will get cancelled. Again, what will be remaining? 1 is equal to 12 by n minus 2, n minus 3. So take it to the other side. N minus 2, n minus 3 equal to 12. Correct? And if we multiply, you have to multiply like this. So the n into n is n square minus 3n minus 2n plus 6 equal to 12. Correct? Yes. So this will be n square minus 5n plus 6 equal to 0, right? And you have to use your tree method to solve this quadratic equation. So this is 6 and here it is minus 5. What are the numbers? 6 ones are 3 twos are 6 we can take, right? Yes. 3 twos are, is it plus 6? No, actually equal to 12. So we have to take this 12 to this side, right? So again, n square minus 5n plus 6 minus 12 equal to 0. So n square minus 5n plus, not plus, it is minus, plus 6 minus 12 is minus 6 equal to 0. So what we have to get? Minus 6 minus 5 we have to get, right? Apo 6 ones are 6, 6 minus 1 is 5. So you have to put minus over here, right? So 1 into minus 6 is minus 6. 1 minus 6 is minus 5, right? So this we can take it as n minus 6, n plus 1 equal to 0, or you can directly take, therefore n equal to minus 6 na plus 6, 1 na minus 1. Okay, so negative value is not possible. Minus 1 we are getting, no? So minus 1 means negative, that is negative value is impossible, right? Therefore, what is your n value? 6. Is that clear? And your second question, in how many ways 5 boys and 3 girls can be seated in a row so that no 2 girls are together? So what is given? 5 boys and 3 girls are there. We have to make them to seated in a row, that is like this. We have to make them to sit in this way. Okay, and your question is how many ways, but no 2 girls are together. No 2 girls should not sit together. This is a condition what given. Okay, so how can we make arrangement? Okay, I can take girl, 3 girls are there. So first we can take boys. Boy, is that right? 5 boys are there. And how many girls are there? 3 girls are there. So 3 girls may take this place or this place or this or this. Correct? So what are the possibilities? Either they can sit here or here or here or here or, so how many ways she can sit? 1 2 3 4 5 6. Is that clear? And boys 1 2 3 4 5. Is that clear? Yes. So here we can take 5 boys can be seated in a row. Is, what is the answer? 5p5. Correct? 5 boys taking 5 at a time. Okay, and what is npn? That is n factorial. So here it is 5 factorial. 5 boys can be seated in a row is 5p5, that is 5 factorial. Correct? So, and next one, girls we have to write, right? And what is the condition? Since 2 girls are not to sit together, so we may arrange 3 girls in 6 places. Correct? 3 girls in 6 places. Therefore, it can be done. Total are 6 places are there. How many girls are there? 3 girls we are taking at a time. So 6 p 3 ways. Correct? Okay. So that's all. You have to write it in the format. So total total number of seating arrangements. Total number of seating arrangements is 5p5 into 6p3. Correct? Okay, what is 5p5 answer? 5 factorial. 6p3, how can we write? Starting from 6, descending 3 numbers. 6, 5, 4. Correct? And this one. 5 factorial means 1, 2, 3, 4, 5. And taking this also. Into 6, into 5, into 4. And use your calculator. This will be, if you multiply, and you will get 14,400. This is your final answer. So 14,400 ways we can make that 5 boys and 3 girls can be seated in a row. And your next question, third one. How many 6-digit number can be constructed? So what we have to do? A 6-digit telephone number we have to form. Okay, and what is given? What are the digits is given? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if each number starts with, okay, so we have to form 1, 2, 3, 4, 5, 6 digit. And it is given that first 2 digit it start with 3 and 5. And remaining 4 numbers we have to find out. Okay, so what are the numbers is given? The given numbers are what are the numbers? 0 to 9 it is given. Okay, so 0 to 9 la 3 and 5 we should not take. So if we leave 3 and 5, again how many digits are there? We have 8 numbers. Correct? So 8 numbers, and how many places we have to fill? 4 places. Correct? Therefore total, as like this problem we saw in a previous exercise, right? So here we are going to use your permutation. So total number of 6-digit telephone numbers are 1 into this is only one time, this is only one time, so 1 into, and totally how many numbers will be remaining? 8 numbers will be remaining. How many places are there? 1, 2, 3, 4 places are there, so 8p4. Correct? So 8, 1 into anything will be same thing. So 8p4 values 8, 7, 6, 5. Correct? Starting with 8, 4 numbers we have to take it in a descending. So 8, 7, 6, 5. Multiplication, use your calculator. What the answer you are getting? 1680 is your final answer. And your fourth question. Find the number of arrangements that can be made out of the letter of the word assassination. So assassination is the word is given. We have to make number of arrangements. So number of arrangement means first we can start up with yes, how many words we can make. Start up with a, how many words we can make. Start up with I, how many. Start up with n, how many. Like that we have to find out. Okay, so your solution, total number of letters in the word assassination. Okay, so this is your total number, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Totally 13 letters are there. Okay, so in the word, how many times A occur? 1, 2, 3. So 3 times. How many times yes occur? 1, 2, 3, 4. 4 times. And how many A we have completed? Next I. How many times I occur? I occur 2 times. Next N. N occur 2 times. Next, T. T occurs one time, and similarly O occur one time. Correct? Therefore, required number of permutation is, okay, totally how many letters are there? 13. So 13 factorial by, since the same word is repeating many times, like A, S, I, N and all repeating many times, that repeating numbers we have to take it in the denominator. Here directly we can't use a permutation formula because many letters are repeating, right? So if many letters are repeating, you have to take the total letter of words. So here total letter of words is 13. So 13 factorial by the repeating numbers we have to take. So 3 factorial into 4 factorial into 2 factorial into 2 factorial. 3, 4, 2, 2 we are taking. Okay, so this is your final answer, and in your book back answer they didn't solve this one. So 13 factorial by 3 factorial into 4 factorial into 2 factorial into 2 factorial is your final answer. So today what we saw, permutation, right? So what is mean by permutation? Number of arrangements. And your homework is example 2.17 to 2.21. Thank you, students.